Hello and welcome back to the channel. Today we're going to be looking at the binary search algorithm. We're going to learn how it works and why it is one of the most important algorithms in computer science. Before we get started, don't forget to like and subscribe for more programming content. Let's first go through a visual to see how binary search works. Then we're going to implement the algorithm in Python. So the main requirement for using binary search is that the list that you're going to be searching through must be sorted. So we're going to take this list as an example, and our target is going to be finding 101. So first we're going to have a lower and an upper bound. The lower bound is going to be at the beginning of our list, and the upper bound is going to be at the end of our list. So in this example, it's going to be at 1 and at 120. Now we're going to calculate the midpoint of our list, which in our case we have 6 elements. So 6 divided by 2 is going to give us 3. So we're going to be keeping track of the third element, and we're going to compare it to our target. Since 25 is less than 101, we're going to be moving our lower bound to the element next to our midpoint, which in this case is going to be at 78. We can remove the remaining elements since we have a sorted list, and the remaining elements are going to be less than our target. Next, we're going to repeat the same process with our new bounds, and we're going to calculate our midpoint, which is going to be at 101, and we're going to compare our midpoint to our target. Now, if we compare our target to the midpoint, we can see that they are equal, so we're going to return the midpoint. Now let's look at an example where the target is located on the right side of our list. Our upper bound and lower bound are going to be the same as before. Then we're going to calculate the midpoint and compare it to our target. This time our target is less than our midpoint, so we're going to be moving our upper bound to the element before the midpoint and eliminate the remaining elements since our target is going to be less than the remaining elements. Next, our midpoint is going to be on the first element since we only have 2 elements in our bounds, and we compare the midpoint to our target. Since the midpoint is less than our target, we're going to move the lower bound to the element next to our midpoint. Now we only have 1 element in our bounds, so the midpoint is going to be on that element as well. Then we compare the midpoint with our target, and since they match, we're going to return the location of our midpoint. Finally, let's look at an example where the target is not in our list. So we're going to have the same process as we did before when our target was 3. At this point, our bounds only contain 1 element, and that element does not match our target. So we're going to return a value, let's say -1, which is going to signify that we haven't found our target. Now we can head over to Python and implement the code. We're going to define a function called binary search that takes in a nums list and a target value. We're going to set the lower variable to the first element, which is going to be at index 0. Next, we're going to set our upper variable to the last element index, which we can get by calculating the length of our list -1. We need the -1 since lists in Python are 0 indexed. Next, we're going to have our loop. Our condition is going to be as long as the lower bound is less than or equal to the upper bound, as we saw in the visual. Inside our loop, we're going to first calculate the current midpoint of our bounds, which in this case, we're going to be using integer division, since index can only be integers. So if we have an odd number of numbers in our list, we can't have a decimal value for the midpoint, so we're going to use integer division, which is going to drop the decimal point. Then we're going to check if the number at our midpoint is equal to our target. If it is, we're going to return the midpoint. Next, we're going to check if the number at our midpoint is greater than our target, and in that case, we're going to move our upper bound to the midpoint -1. So here we're using a -1 since we already checked the midpoint in the first if condition, so we do not need to consider the midpoint again. Finally, we're going to check if the number at our midpoint is less than our target. We can do that using an else statement. And if it is, we're going to move our lower bound to the midpoint +1. Again, since we already checked the midpoint, we're going to add 1 to the lower bound. And finally, if nothing is returned from our while loop, that means the target was not found. So in that case, we're going to return -1. Finally, we're going to have our print statement and we're going to call our function with the example list we saw in the visual. Now we can save our file and open the terminal, and we're going to run our file using the Python command. As you can see, we get 4, which is where 101 is located in our list. Now we can go back to our code and change our target to 3. So this should return 1, which is the index of where the number 3 is located. So we're going to save our file and run our code again, and we get 1. Finally, let's test a target that does not exist in our list. So we're going to put in 10. We're going to save our file and run it again. As you can see, we get -1. So this has been an in-depth guide to the binary search algorithm. Thank you for watching, and don't forget to like the video and subscribe to our channel to show your support.